Standard unit vectors are the vector I, which is component-wise 1, 0, so 1 unit along the x-axis, none in the y. And the unit vector j, which is a unit vector in the y direction, so component form would be 0, 1. And I could go to the time and trouble and make I and j bold like this, but it's too much typing to do that. So I'm just going to write, when I write I and j, if I don't make them bold like this, you'll understand that they are vectors. So now we can represent the vector v, which is in component form would be 2, 3, as 2i plus 3j. That's just a different format for writing a vector. Notice this 2, 3, it would make an assumption that this is one of the many vectors, but this is the one whose tail is at the origin. Same with this, right? Because it really is the same vector. So, let u be the vector in component form 2, negative 4, and v be the vector negative 4i plus 5j, and let's play a little mix and match here. If a directed line segment representative of u has initial point 5, 7, what is this terminal point? Well, it would be 2 more than 5 and negative 4 more than 7. So I guess the answer to that question would be the point, oops, sorry, wrong one. The point 7, the x component, well no, the x value would be 7 because it's 2 more than the 5, and the y value would be negative 4 more than the 7, so 7, 3 would be the terminal point. Okay, now here's a question. What is u plus v? And what is u minus v? Well, u plus v, we just add the components. I guess I'd call it negative 2i plus j. So negative 2i plus j. Is that clear? Why it's negative 2i plus j? Because I just add this 2i to this negative 4i, and I get negative 2i. And this negative 4j plus this positive 5j, and get positive 1j. So what would be u minus v? Okay, u minus v, maybe for a change I'll make this be in component form. Since we ought to be able to go back and forth between them, that would be 2i minus negative 4i, or we'll call that 6i, but in component form that would just be 6. And for the j part, u minus v, negative 4 minus 5, so negative 9 would be the y component. Okay. Now, what is the length of v? And the length of v, I guess, would be the square root of negative 4 squared plus 5 squared. So if my calculations are correct, square root of 41. And whoops. That is a bit of a problem there, isn't it? Well, I didn't mean for that to go to the next line and come over this other stuff that it wasn't supposed to come over. Let me see if I can, there. I'll cut that and say, I'll paste the, oh, that didn't help. Alright, we'll undo that. And I will move this line out of the way. And now I'll paste it in there. Let's say there, square root of 41 is the length of v. Example 4. Give a unit vector in the direction of u and a unit vector in the direction of v. Well, since I already got the length of v here, I could definitely do that one first. A unit vector in the direction of v would be 1 divided by the length of v times v. And so that's pretty easily deciphered. It's just going to be 1 divided by the square root of 41. And then that is multiplied by our v vector, which is negative 4i plus 5j. So in parentheses, negative 4i plus 5j. And oh, we're not supposed to be a capital J. That's supposed to be a small j. There we go. I don't know why it was highlighted. I didn't highlight it, but for some reason or other it got bolded there by accident, I guess. There. So if you wanted to write it as negative 4 over the square root of 41i plus 5 over the square root of 41j, or we could really have fun. Negative 4 square roots of 41 over 41i plus 5 square roots of 41 over 41j. That would also work. But we didn't give a unit vector in the direction of u, but in order to do that, we need to find the length of u first. Why don't you pause here and see if you can figure that out. Okay, resuming from that pause, the length of u is equal to the square root of 2 squared plus negative 4 squared. And who would fault you if you said 4 squared? No one would fault you for that. And so that would give us square root of 4 plus 16 square root of 20, which is 2 times the square root of 5, right? You know where I got that from, I hope. And so what we really want to do is say the unit vector in the direction of u is 1 divided by, oh, I'm going to be sneaky, copy, paste. It's 1 divided by 2 times the square root of 5. Not sure why I got parentheses there. It's not really required. Oh, but that was, so let's undo that. I guess it is required. I didn't think it was, but it must be with the software thing. Times, I guess I should say 2i minus 4j. 2i minus 4j. And could I simplify that? I think a tad. We could call this 1 divided by root 5 times I, and then minus 2 divided by root 5 j. And if we wanted to have fun, we could say, hey, gee, well, why do I know that that's a unit vector? Well, we could find the length of this vector, which would be square root of 1/5 plus 4/5, which is the square root of 5/5, which is the square root of 1, which is 1. So therefore, you can see a little mental check there that we did it correctly. That is a unit vector. At least we did it correctly enough that we know we got a unit vector as an answer. That's a good thing.